Okay, today we are going to focus on rotations. Rotations can be the trickiest at first because you're going to have to keep referring to your notes, but once you get used to them, you'll realize they're actually one of the easiest. Let's first make sure you understand rotating. I'm going to put a point on this graph. I'm going to put it here at 1, 2. So my original point, we'll call it point P, P for point, is at 1, 2. Right now it is in quadrant 1. If it moves 90 degrees clockwise, that means it'd follow the direction of a clock, and it'd land somewhere here in quadrant 2. I'm going to find that somewhere. I'm going to switch to yellow so you won't be able to see it real well, but we don't want it to pop so much. What's going on in a rotation is it's rotating around the origin. Imagine it has a rope tied to it, and you're swinging it around your head, and the origin's your head. So that rope is not going to change distance. So I know the length of that rope is going to stay the same, but it's going 90 degrees clockwise, so it's going to go down here somewhere. In fact, it ought to be right here, and let's check if that's right. So now I'm going to switch to green. In the past, when we have found the length of diagonals, we'd focused on that rise and that run, that slope triangle. So we're going to go back to that. From the origin, I'm going to find that slope triangle of the original. The rise was 2 and the run was 1. Now look at what's going to happen. Now it's going to switch to where now my run is 1 and my run is 2 and my rise is 1. So it just kind of reverses. In fact, let's go ahead and find the ordered pair for P prime. That ordered pair is the x is now 2 and the y is now -1. Well, let's compare this. I should not have put that prime symbol right there, so let's get rid of it. P prime is now at 2 and -1. So look at what's happening. This 1 and that 2 switched spots. It became 2, 1. And then that sign of what was in that y value changed signs. Why did it change sign? Because it dropped down 1 quadrant. So moving 1 quadrant is going to change the signs of one of your values. Okay? And moving 1 quadrant is going to cause the x and y values to reverse. Now let's go ahead and I'm going to see if I can erase all of this. Let's look at a 180 real fast. So let's go back to another point. Let's put it at 2, 3. Imagine that rope. So the 180 is going to be the rope over here on the other side. So it's going to move 2 quadrants. Let's look at that rise and the run. The rise is 3 and the run is 2. So let's check and see if the rise just goes down 3 instead of up 3 and the run goes to the left 2 instead of to the right 2, would that line up in a straight line? Yes, it does. So if this is P at 2, 3, P prime is now at -2, -3. So comparing those, P is at 2, 3, P prime is at -2, -3. Now look at what's going on. The signs of both values just changed. Nothing switches, nothing reverses, just change the signs of everything. Okay, now going 3 quadrants would be a 270-degree clockwise. However, what if I just went the opposite direction? What if I went counterclockwise? Now I only have to go 1 quadrant. So that's a 90-degree again, but the opposite direction. So therefore, that's why it's going to be a similar thing that we're going to do. We're going to switch the values of the x and y, but it's going to be a different coordinate or value that I changed the signs of. Let's go ahead and look at the recap on everything so that we get this straight. If you're working with 90-degree clockwise, that's the same as the 270-degree, the opposite direction. Okay, first thing you're going to do, you're going to switch or reverse the x and y values. If you were at 2, 3, change it to 3, 2. Then you're going to change the sign of what is in the Y spot. So I would just come over here to my Y spot, change the sign. A 180-degree clockwise. All you have to do is change the signs of everything. So if you are at -1, -4, change it to +1, +4, and you'll have a 180. Now, the 270-degree clockwise is the same as 90-degree clockwise. We're working with the same values, so the directions are similar with one little change. First direction should say switch, not which, by the way. Switch or reverse the x and y values. So if we were at -5, 4, switch it to 4, -5. Here's where the change occurs. Change the sign of what's in the x spot instead of the y spot. So I'm going to change the sign of that -4. Okay, so that's the one where I say you're going to want to watch your notes, because you'll probably keep wondering, oh, which one do I change the signs if you're working with that 90 or 270. All right, let's go ahead and look at this one. On this one, I just screen captured the answer so that I can use that to help you understand. A rotation of 90 degrees counterclockwise means I'm going to go this direction. So see, here's the original. It's rotating around this way in this circle around that origin. So that's how they knew it moved up one quadrant, because every quadrant is 90 degrees. Okay. Now let's look at the original f. The original f is at 2, -2. F prime, well, it's at 2, +2. Now, it's hard to tell because they're all 2's, but the 2's did reverse, and then look at what happened. Change the sign of what's in the y value. All right, let's go ahead and look at this. A rotation of 180 degrees around the origin. Okay, so since it's a triangle, I'm going to have to do each one individually. Here's how I work with this. We're going to list out the order of pairs for S, T, and R. S is at 0, 3. T is at -1, -1. And R is at 4, -1. Okay, 180 degrees means change the sign of everything. So I'm going to switch colors. 0 does not change, just change the 3 to a -3. On those ones, they both go to positive. The 4 changes to a negative, and that -1 goes to a positive. So now, because I switched the signs of everything, I can now put the prime signs here. So now let's go ahead and plot it. S prime is at 0, -3. So 0, -3 here, S prime. See, those would line up in a straight line, the S and S prime. Okay, T prime is at 1, 1, which is here. Look, those would line up in a straight line. And then R prime is at -4, +1. And those would line up in a straight line. So we got R prime. So now all I have to do is complete the triangle. And there's my 180-degree rotation. All right, let's look at 90 degrees clockwise. So what are we going to do? We're going to switch each order pair. And then which one are we going to change the sign of? We're going to change the sign of what's in the y value. Okay? So let's list out. We got J, I, and K. We need the order pairs. J is at 3, -2. I is at 4, -2. And K is at 3, -3. Okay, so this one I am going to have to rewrite out because I have that switching to do. So I'm going to just reverse everything, go -2, 3, -2, 4. I'm just switching the x and y's, then -3, 3. Okay, now I've got to change what's in the y values. So let's go, 3 becomes -3, 4 becomes -4, 3 becomes -3. And this should give me a 90-degree clockwise. So let's plot -2, -3. There's J prime. -2, -4. That's I prime. And -3, -3. K prime. Did we move one quadrant clockwise? Yes, we did. So we can confirm that we should have a 90-degree clockwise rotation. All right, now these are finding the rules, okay? So what I'm going to do is I'm going to compare, well, these Q's don't really help me because they're not changing. That's the reason they're not changing is they're on the origin. So let's look at S. Let's count how many quadrants did it move. Here's 1, there's 2. Move 2. If I were to confirm that with R, switching colors, here's R, that would be 1, and then look, 2. So it seems to move 2 quadrants. When something moves 2 quadrants, that's 180 degrees, and we typically don't even worry about direction because you could go clockwise or counterclockwise and they'd be the same. Let's go ahead and look at this one. When finding the rule, you compare each point with its prime and see how many quadrants it moved. So here's E. E came over here, so that's 1 quadrant. So I know I'm working with a 90. Did I go counterclockwise or did I go clockwise? I went 90 degrees counterclockwise. I'm going to label that as CC, which is the same thing as 270 degrees clockwise. So either one of those would be a correct answer.